Okay, at this point, we're going to go ahead and take a look at some of the notes on page 190 and 191, because what you're seeing on the note side in the examples of 190 and 191 is really what you're going to spend time doing in the homework this evening. So the first thing they're going to ask us to do is to simplify square roots. And the first question that they have there in number 1 is asking us to simplify the square root of 48. Now, what they're not asking me to do here, what they're not asking me to do is anything involving a calculator here. They're not asking me to get a calculator out and just punch in square root of 48 and say what the numeric value is that pops up on the screen there. That's not what they're asking me to do. What they're asking me to work on is really called simplest radical form here. And what simplest radical form is me taking out any perfect square roots that are formed in the product of making that number there, leaving behind what I can't take out and writing that as a solution. So what you're going to have to do first is write 48 as a product. Of course, product means multiplication, so what I'm asking you to do is write this as a multiplication problem. You can write this with as many components as you want. If you can find 2 numbers that multiply together to make 48, go for it. If it's 3 numbers, if it's 4 numbers, if it's 5 numbers, you can do anything you want. To make the process simpler, though, what you're going to be looking for when you write those products are numbers that are perfect square roots. So really what you want to use here are your numbers like 4, because the square root of 4 is 2, and you want to use 9 because the square root of 9 is 3, and 16 because the square root of 16 is 4, and 25 because the square root of 25 is 5, and 36 because the square root of 36 is 6, and 49 because the square root of 49 is 7, and 64 because the square root of 64 is 8, and on down the list you go. That'll probably be about as large as you would need to go in my type of assignments, but any perfect square root will fit the list. So if it's 100 that you need to pull out, then you pull out of 100, because the square root of 100 is, of course, 10. All right, so going back to what we're talking about here now, all right, we're going to make 48 any way we can. One of the ways I see that we can make 48 here is we can use 16. So I'm going to rewrite the square root of 48 as 16 times 3. 16 times 3 does multiply together to make 48. That's an essential check. But what you're going to do now is you're kind of going to separate these into their own little problems. This is really going to be the same as the square root of 16 times the square root of 3. Well, we know about the square root of 16. The square root of 16 is equivalent to 4. So I'm going to simplify this. Square root of 3, that doesn't simplify. That's not a perfect square root. So the square root of 3 is going to stay the square root of 3. So this is actually going to change into 4 root 3. And that's what the square root of 48 is in simplest radical form. It's 4 root 3. Now, there's other ways to get there. Some of you might have looked at the 48 and said, I want to use 4. We can do it with 4. We can go the exact same idea here. All right, if I'm going to use 4, then the other number is, of course, going to have to be 12, because 4 times 12 is 48. So we can separate those, but the thing is, 12 is not fully simplified, because I can still pull something out of 12. 12 is, of course, the same as 4 times 3. So this is really root 4 that I already had, and then 12 is going to change into 4 times 3. Now we can pull this apart like we did the last one, but it's actually going to have 3 components. Root 4 times root 4 times root 3. Well, the square root of 4 is 2. The square root of 4 again, 2. And then you've got root 3, which doesn't change anything. Well, 2 times 2 in the front here is going to change into 4, so we've got 4 root 3. So as you can see, same answer. Did it take me more steps to get there? You bet, absolutely. You can tell just from the length of how I wrote these that it is a longer way to get there, but we do end up with the same answer. One of the things that this route also is good at pointing out here is whenever you have 2 roots that are the same, you can just pull that out as the same value. So for instance, if you had root 3 times root 3, that's just going to simplify out and be a 3. Here, when I had root 4 times root 4, a couple lines down, I saw that it changed just into 4. That's going to work all the time. Root 6 times root 6 will eventually just change into a 6. Root 21 times root 21 is just going to change into 21. All right, it doesn't matter what it is. It's true whether it's a perfect square root or not. All right, so let's practice that one more time. They've got the square root of 180 as a practice question for us. So let me go ahead and erase what you have here, and we'll go ahead and practice with square root of 180. So they're asking us to simplify here the square root of 180. All right, so be thinking of numbers we can multiply here. Most of us would like to say, oh, 18 and 10. But if we look at that list, 18 and 10 aren't on that list. Can we work with 18 and 10, though? Absolutely. As far as 18 and 10 goes, '18 is something I can work with, because most of us know 18 right off the top of our heads. 18, right, that's going to involve a 9 and a 2. Now, as far as this goes, we can bring this out as a 3, but what we have left here is 20. And I don't want you to sit there and go, oh, there's nothing we can do with 20. There is something we can do with 20. So let's do a little bit of a separation here. I'm going to pull this square root of the 9 out and bring that out as 3. But what I have now is 3 root 20. All right, well, 20 we know is 5 times 4. And that helps because 4 is another perfect square root. The square root of 4 actually comes out as a 2 because the square root of 4 is a 2. Now you're saying, well, wait, I've already got a number out there. How do I do that? Remember, this is just a giant line of multiplication. So when I bring the square root of 4 out as 2, to combine it with the 3 that's already there, that's going to change into a 6. So that's going to end up as 6 root 5. Now you might say, oh, that was really confusing. That looked like a lot of work. Can't we do this an easier way? Absolutely, we can do this an easier way. We don't have to pull things apart and then recombine and then pull things apart again. We've just got to find a better number to multiply with here. The better number to multiply with here is going to be 36. If I change this into 36 times 5, all of a sudden it's a much simpler question. When I pull these apart and write root 36 times root 5, the square root of 36 is a perfect square root because it's on my list. Square root of 36, that's equal to 6. There's 6 root 5. Same solutions, obviously, it has to be, but obviously a whole lot less work. So what you do here kind of just depends on what numbers you're willing to work with. Chances are the bigger number you're going to choose to work with, or further down on that list, the shorter your amount of work is going to be overall in simplifying that into simplest radical form. So then what they do, if you go over and look at example 2 on page 191, is they have us simplifying some questions with the concept of simplest radical form here. So let's go ahead and take a look at those. We'll do a little bit of an introduction, which I don't think will be a big deal, because a lot of what you've seen with variables here is the same type of idea that we're going to use here with adding and subtracting when it comes to roots here. I'm going to go ahead and leave those perfect square roots on the screen because we may end up needing to do simplest radical form again in order to be able to go ahead and add here. So let's start off with a simple problem, and then we'll get to questions more like exactly what you see on the page there. Let's start off with a question like 5 root 2 plus 3 root 2. Now, even though this looks like something new and kind of scary, it's not. Think of those root 2's just like variables. Let's say it said 5x plus 3x. Well, you would know exactly what to do if it said 5x plus 3x. If it said 5x plus 3x, you'd say, okay, I have 5 x's, and then I'm going to give you 3 more x's, and you'd have 8 x's. You do the same thing here with the roots. Treat them just like you do with the variables. If I give you 5 root 2's, and then I give you 3 more root 2's, how many root 2's do I end up with? Well, I end up with 8 root 2's. That's the solution. That's all you have to do. The same thing can work with subtraction. If I have 7 root 3's, and I'm going to subtract 2 root 3's, how many root 3's do I have? Well, I would have 5 root 3's. If I start at 7 root 3's and I take away 2 of them, I end up with 5 root 3's left. So as you can see, we know how to do that because it's the exact same as a variable. Now, obviously, what's going to have to be true, though, is these roots are going to have to be the same. If I give you a question like 3 root 4 plus 1 root 3, because these roots are different, you can't do this thing. Just like if we had different variables. If I say 7x plus 2y and say simplify, you're going to look at me and say 7x plus 2y, it's already simplified. That would be correct. Same thing. I can't do anything with this other than maybe simplifying the root 4, but as far as putting these together, it's not going to happen. All right, so now what they're going to do, instead of giving me the same roots, is they're going to say, okay, now I'm going to give you some different roots, but see if you can make them the same and make this happen, which sometimes we can actually do. If there's clearly no way to do it, it's going to end up just like this, where I'm going to say no way and I'm going to go home. So let's erase those and do the questions in example 2 there. And the first one there in example 2 says 3 root 2 minus root 8. Now, the one nice thing about this type of question is they're kind of giving this away. Because if we look at this, there's nothing else I can do with 2 to make this any simpler. All right? The smallest number I could pull out would be 4, because the square root of 4 equals 2. There's no point in me talking about pulling out the square root of 1, because that's 1 and it's not going to change anything. So I know I'm going to have to keep root 2 behind. So chances are that's a number that's going to come into play over here. Well, let's look at what we've got over here. Square root of 8. That's the same as 4 times 2. Well, if we separate that into 2 separate pieces, square root of 4 is something we can change. The square root of 4 is equal to 2. So that's going to actually change out to be 2 root 2's. And all of a sudden now we have a problem that actually simplifies. Because I have 3 root 2's minus 2 root 2's. Well, if I have 3 root 2's and I take away 2 root 2's, I'm left with 1 root 2. And that's the solution. 3 root 2 minus root 8 is the same as 1 root 2. Let's try that again with the B problem. A little bit different, but still works. Root 12 plus root 75. Now, we're actually going to have to think about this one because 12 isn't going to feed into 75. So we know 12 isn't going to be the other number over here. But let's start with the 12 and see where that takes us. Well, there's only 2 numbers we can really pull out of 12 to simplify. That's 4 and 9 because those are the only 2 that are smaller than 12. We know 9 isn't going to come out of the 12, so it's got to be 4 that's going to come out. So we're going to rewrite the 12 part as 4 times 3. Well, when we separate that, root 4 times root 3, we know that that root 4 is going to come out as a 2. So that ends up being 2 root 3. And that's very helpful now because now that we've done the work on it, we know that one of the other numbers over here is going to have to be a 3. Well, I can make that work with 75 because we know that 3 times 25 is 75, and one of the numbers over here is 25. So we're going to add on to that what is now 25 times 3, or when I separate it, root 25 times root 3. Square root of 25 is 5, so that's the same as 5 root 3. So this is actually 2 root 3's plus 5 root 3's, and that's going to give me 7 root 3. All right, so let's practice this with one more question here. It's not on the page, but it's the same idea here that we're going to be doing. And so let me get these off of here quickly. I'll erase this as fast as I can. And the question I'm going to have you work with here is going to be square root of 98 minus 7 root 2. Now this again is not too bad, because when we look at this side over here on the right, we see the root 2 and we know that can't go any smaller, because we know the smallest number we could pluck out would be a 4. That isn't going to help me there. So this is already simplified. So let's do something with 98 that involves 2. Well, I can make that happen because 49 times 2 is 98. So this is the same as root 49 times 2. Again, why? Because 49 times 2 is 98. Well, when I separate this out and write it as root 49 times root 2, we've got the square root of 49 here, which equals 7. So this is actually 7 root 2. All right, that's this left side. Well, that's kind of nice, because notice what it says now is I'm supposed to now subtract 7 root 2. Well, if I have 7 root 2's and I take away 7 root 2's, of course I have nothing left. So the square root of 98 minus 7 root 2 equals 0.